Hello viewers, welcome to my channel. Today we shall be looking at the topic rationalization of surd, of which we have three questions on the board to solve. And the question read, rationalize the following. Number 1, 5 over root 3. Number 2, 7 over 2 root 5. Number 3, we have 1 plus root 2 all over 2 minus root 3. All right, so to rationalize a surd, that we go with a certain question that is being presented in the form of a fraction. When a question is presented in the form of a fraction and the denominator of that particular fraction is a surd, in that sense, you can be asked to rationalize the surd. As you can see in number 1, we have the denominator root 3. Number 2, we have the denominator 2 root 5, which contains a surd. Once in that fraction, the denominator side of the fraction contains a surd. As you can see in these various questions, that is when you will be asked to rationalize the surd, thereby making your final answer whereby the denominator will no longer contain anything that has to do with surd. For example, if I have root A over root B, how do I rationalize this? And why must I rationalize this particular question? I can only rationalize it when the denominator of that particular fraction has to do with a surd. So to rationalize it means that I'm going to be considering whatever I have in the denominator as a surd and use that particular number to multiply the up and down of that particular fraction. So in this particular one, what I have in the denominator as a surd is root b. So to rationalize this means that I'm going to be multiplying both the up and down of this particular question to be rationalized by the denominator, which is what? A surd. That will now look like this, root b over root b. That is to say, we use the denominator side of that particular surd to multiply the up and down of that particular fraction. So by so doing, I will now have it this way. Root a multiplying root b will give me root ab all over root b multiplying root b will give us b. Recall that if we have root 3 multiplied by root 3, that's supposed to give us root 9, of which we know that the square root of 9 will give us what? 3. So instead of writing root 3 times root 3 equal to root 9 and eventually write it as 3, I can write it straightforward from this particular point. Root b multiplied by root b will give me b. Because by so doing, if I have root b multiplied by root b, I'm supposed to have root b squared. And the square root of b squared is what? B. So that's exactly how we are to rationalize a particular question or fraction that contains surd as a denominator. All right, so if you have a question like this, for instance, root 3 over 5, you won't be asked to rationalize this because this one is already rational in its sense. It's only when you have a root here that is a surd that you can be asked to do what? Rationalize. Now let's take a look at the questions we have on the board. We are going to be using number 1, number 2 to follow the same approach I have shown you now. And number 3 has a different approach, though with the same concept of multiplying the up and down. But we are going to be doing a very different thing with the expression we have on the denominator. Because in number 3, we have an expression as a denominator, an expression that contains a surd, of which we are going to be doing something with that particular denominator. Now, to solve these questions, that is to rationalize them, number 1, look at what we're going to do there. Here we have 5 over root 3. So how do we rationalize it? Recall that we use the denominator of that fraction, which is a surd, to multiply the numerator and denominator of that particular fraction. And by so doing, we have it as multiplied by root 3 over root 3. So 5 multiplying root 3 will give us 5 root 3 all over. Root 3 multiply root 3 will give us 3. So this becomes the answer to this particular one. Then for number 2, question number 2, here we have 7 over 2 root 5. So similarly, we are going to be taking the denominator, the product of this denominator that contains a surd, of which we have it as 2 root 5, to multiply both up and down in order to keep the answer rational. As you can see in the answer to this particular question, what we now have as a denominator is no longer a surd or root. It's now an ordinary number. So using the denominator here, that will be 2 root 5 all over 2 root 5. Then to go further, 7 multiplying 2 root 5 will give us 14 root 5 all over 2 multiplied by 2 will give us 4 already. Then root 5 times root 5 will give us 5. Just like saying root 5 times root 5, that's supposed to give us root 25. And the square root of 25 will give us what? 5. So let's now move further. Finally, we have it as 14 root 5 all over 4 times 5 will give us 20. We can actually reduce this to the lowest term because this is a product. Okay, so to reduce it to the lowest term, we now have it as 2 divide this will give us 7. Then 2 divide this will give us 10. So we can't go further than this. So the final answer will now be 7 root 5 all over 10. So this is the final solution to this particular question. As you can see, whenever you have this as a question that's a fraction and you are asked to rationalize, at the end of the day, the number you'll be having on the denominator must not be a surd, like in the case of this and this. I hope this is quite clear. Now let's move to number 3. Number 3 is quite a different approach. Though it's similar but different approach on what we are going to be doing with the denominator here. So keep your fingers crossed as we move to number 3. Please don't forget to click on the subscribe button as we continue to make mathematics easy and simple for you. Now for the number 3 question, the question reads 1 plus root 2 all over 2 minus root 3. How do we approach this particular one? We are going to be taking a similar approach as of this one, but with some slight adjustment with what we're going to be doing with the denominator here. If you look at the denominator here, we have an expression which is 2 minus root 3. So what we're going to be doing here is that we'll be doing the same thing of using what we have on the denominator to multiply the up and down, which is what the numerator and denominator will be making use of this. But what we are going to be making use of, as far as the denominator is concerned, is the conjugate. The conjugate of the denominator is what will be used to multiply the up and down. Whenever you are dealing with an expression as a denominator that contains a surd, so what you are going to be using to multiply the up and down is the conjugate of the denominator. So what do we mean by this conjugate? Let me give you some instances. If you have, for example, 5 plus root 7, what is the conjugate of 5 plus root 7? The conjugate of 5 plus root 7 is 5 minus root 7. What is the difference between the two? The difference is, of course, the sign. So the conjugate is just the opposite of the sign you have here, just interchanging between the signs. So the conjugate of 5 plus root 7 is equal to 5 minus root 7. And also, the conjugate of 5 minus root 7 is as well 5 plus root 7. Now, answer this one. If I give you 20 minus root 5, what is the conjugate of this expression? Can you answer the question? The conjugate of this expression is 20 plus root 5. I hope the issue of conjugate is not a problem now. So what we'll be doing with this particular one, this kind of fraction, is to multiply the up and down, that's numerator and denominator, by the conjugate of the denominator, which contains a third. Now let me show you how to address that. Now, using the conjugate to multiply the numerator and denominator, what we are going to be doing is this. What is the conjugate of 2 minus root 3? Of course, the conjugate is 2 plus root 3. We use the same thing to multiply the denominator, which is 2 plus root 3. We are going to be faced with the expansion of some expressions here. You must be familiar with the concept of expanding algebraic terms or an expression. Look at what I'm going to do here now. If you have 2 plus x multiplied by 3 minus x, for example, how do you expand this? Because that's exactly how this one will look like. So to expand this means that we have to use all the terms that we have here to multiply everything that we have here. That is to say, 2 will multiply everything that we have here. That will be 2 multiply this. After with 2, we equally multiply this. When we are done with using 2 to multiply all of this, then we'll now use plus x to multiply 3 and equally use plus x to multiply minus x. So that's exactly what we're going to be doing now in expanding this. And for me to do that, that will now be 2 multiplied by 6. 3 will give us 6. 2 multiplied by minus x will give us minus 2x. Then plus x multiplied by 3 will give us plus 3x. Then plus x multiplied by minus x will give us minus what? X squared, because plus multiplied by minus will give us minus. This is exactly how we are going to be expanding this. I believe you are familiar with the expansion of algebraic expression. All right, so let's get the solution of our question here. Please don't forget to click on the subscribe button to support the channel as we continue to make mathematics easy and simple for you. Then to do this will not mean the whole of this multiply this, which is same as 1 plus root 2, then multiply by 2 plus root 3. All over the same thing with the denominator. That's 2 minus root 3 multiplied by 2 plus root 3. This is exactly what we have here. Then to go further, we have to do the expansion. Recall how I did the previous one I just showed you. That will now be this multiplied by this multiplied by this. All right, so that will now be 1 multiplied by 2 will give us 2. 1 multiplied plus root 3 will give us plus root 3. Then it's now the turn of plus root 2 to multiply everything. Plus root 2 times 2 will give us what? Plus 2 root 2. Plus root 2 multiply plus root 3 will give us plus root 6. This is exactly what we have there. Then all over, let's expand this. 2 multiply 2 will give us 4. Then 2 multiply plus root 3 will give us what? Plus 2 root 3. Then it's now the turn of minus root 3. Minus root 3 multiplied by 2 give us minus 2 root 3. Then minus times plus will give us minus. Then root 3 times root 3 will give us 3. Remember that root 3 times root 3 is supposed to give us root 9, of which the square root of 9 is 3. That's why we have it this way. Then to go further, there's no like term to be collected here. If you recall, based on what we did in our previous video, where we talked about like sorts, we don't have like sorts here for us to bring them together. Because some students will normally put it this way, this plus this plus this. No, you can't add them together because they are unlike sorts. All right, just like someone having x plus 2x, 2y rather, plus 3z. So can you actually bring all of them together? No, you can't bring them together because they are unlike terms. Likewise, this particular one, we have a root 3 here, we have root 2 here, we have root 6 here. So they are never like root, of which we are not going to bring them together. Okay, so there's no like term to be collected on the numerator. But when you look at denominator, you find out that 2 root 3 and 2 root 3 are the same, and these ones are whole numbers. So we now have it as 2 plus root 3 plus 2 root 2 plus root 6 all over here. 2 root 3 minus 2 root 3 will give us 0. So this 2 becomes 0. Because when the same number subtract itself, it will actually give us 0. So when 2 root 3 minus 2 root 3 gives us 0. So we're now left with what? 4 minus 3. And 4 minus 3 will give us 1. 1. So when you now have this expression, 2 plus root 3 plus 2 root 2 plus root 6 divided by 1 will give us exactly what we have here, which is what? 2. Please let me use a different marker. The final answer will be 2 plus root 3 plus 2 root 2 plus root 6, because we can't bring them together any longer. They are not like root, so they're not going to come together. So this is the solution to this particular question. I hope this is quite clear enough. All right, so please don't forget to click on the subscribe button as we continue to make mathematics easy and simple for you. So do have a lovely day ahead. You can comment on the comment section. Tell us your difficulties, any of the steps that you do not understand, so that we can put you through. All right. Do have a lovely day ahead. Bye.